All right, so we're going to go ahead and review domain and range. Before I get to domain and range, I want to refresh us on interval notation. Interval notation represents a span of numbers or span of values or numbers from the lowest to the largest. Okay, and I'm just going to say we use parentheses and brackets. Okay, and I'm just going to put down here parentheses are used for no inclusion. Okay, and brackets are used for inclusion. Meaning if I say I want all the heights of people who are 5 feet and above, that means I'm including the people who are 5 feet tall, and they can be anywhere taller from that. So I would use a bracket on the 5. Okay, if I say I want people who are specifically taller than 5 feet, I wouldn't include 5 feet, so I would use a parenthesis at the 5. Okay. All right. Set notation, however, is a set number of values. Okay, we're not saying from this value up to this value and every possible thing in between. We're just saying it could be this value or this value or this value or this value. Okay, there's a set of numbers. Okay, so I'm just going to say we use curly braces to list the set of values we are considering. Okay, and there's our curly braces. Okay, all right, so now we have our symbols down. Let's go ahead and talk about what domain and range is. Domain is the set of all possible inputs. The set of all possible inputs, okay? Or I'll just put in parentheses, this is the places where there are X values. Okay? Domain, so that's our X's. Range is our Y's. So this is the set of all possible outputs. Okay, and again, this is the places where there are Y values. Okay, all right, so we're looking, where is X defined? Is there some place on my graph, is there some point for every X value, all possible ones? Or are there only certain X values? Okay, so we're looking for all possible inputs, all possible answers, and range, we're looking for all possible outputs. So let's go ahead and look at some of these. Notice it says, determine the domain and range, express your answer in set notation. Anytime you see set notation, that means we're going to be using the curly braces. Okay, so remember my domain is the set of all inputs, okay, which is my X's. So here's an X, okay, here's an X, here's an X, here's an X. So my domain would be all those X values. So I have 2, 4, 5, and 7. Okay. Now my range is all possible outputs, which here would be my Y values. So here I have 3, 5, 6, and 8. 3, 5, 6, and 8. If any of them happen to be repeated, you only have to list them once. Okay. Let's look at the next one. Again, my domain values are my input values. So here my input values are -2, 2, 4, and 5. I always like to list them in the correct order. Okay, so we have -2, we have 4, we have 5, we have 2. I always list them from smallest to largest. Okay. Okay, so we have -2, 2, 4, and 5. And then to find our range, we just look at our y values or our outputs. Here are y values. We have 3, 3, 2, and 3. Okay, so basically I have 2 and 3. I don't have to list it more than once. Okay. All right, let's look at one more and then we'll look at some graphs. Same thing here. If I look at our domain, domain is the set of all input values. So we have 0, 4, 5, and 22. 0, 4, 5, and 22. And then our range values are all of our outputs. So notice here, all of our outputs are the same, right? If they're all the same, I don't have to list it 4 times. I'm just going to say my range is just -1. Okay? All right, let's go ahead and look at it from a picture. Okay, notice here we're talking about interval notation. When we have interval notation, we're either going to use a parenthesis to a parenthesis to a bracket to a parenthesis, or a bracket to a bracket. Okay, I don't use set notation unless I have to. Okay, so here we look at domain. Remember, domain is our x's. So if I look at my x values from left to right, where do my x values start? Where do they end? Okay, notice to the left, if I'm looking on the x-axis, if I trace values, like I can come down here and find a value, I can come down here and find a value, I can keep going, right? No matter how far I go, I'm going to keep finding x values, right? Even if I pick an x value over here, this is eventually going to come over there and I'll be able to trace it up and find an x value. So since that keeps going out to the left, that means that my x's keep going in the negative direction as far as I can possibly go, which would be -infinity. Now, because -infinity is not an actual number that we could say, okay, it equals -infinity, okay, we always use a parenthesis with -infinity and +infinity. So here, the furthest to the left I can go is -infinity, and now I look in the right direction. To the right, same thing, I have an arrow. So no matter how far out I go on my x-axis, I'll always be able to trace it up and find a point on this graph. So this one goes from -infinity to +infinity. And an infinity symbol, if you haven't seen it before, is like a number 8 that's laid on its side. Okay. All right, now I want to look at the range. The range is my y values. And notice here, my lowest y value is this point right here, which is 1, 2, 3, 4. And it goes through that point. So I'm going to start at 4. Because it goes through that point, I'm going to use a bracket. And then I look for my highest y value. So if I go up my y-axis, notice I can trace it over to either side of the line and still find a point on that graph because my arrows are going to keep going up. And if my arrows keep going up, then no matter how high I go, there's always going to be a y value defined there. So it's going to go up to +infinity. Okay. Let's look at the next one. Same idea. I look at my x's first. The furthest to the left that I can go on my x-axis, it's going to keep going and going because I have an arrow that's pointing to the left. So it's going to go back to -infinity. So I'll start looking to the right. As I start traveling to the right, notice I have defined point, I have defined point, I have defined point. I have defined points until I get to this point right here, and then my graph stops. So if my graph stops, my interval notation has to stop. So this value that it stops at is x equals 3. So I'm going to say from -infinity to 3. And then because there is a closed dot, okay, the only time it is not included is if we have an open dot. So here, since this is a closed dot, I know that it stops at 3 and it's including 3. So I'm going to use a bracket. And then I have another piece. So when I have another piece, I use the union symbol. Okay, so my other piece picks up at the x value of 4. And since there's a closed dot there, I'm going to include 4. So then from 4, as I keep tracing on out to the right, notice I can trace this up and I'll be able to find a point on this graph because it's going to keep going and going because my arrow keeps going to the right. So this is going to be from 4 to +infinity. And remember, infinity always has a parenthesis because you can't equal infinity. Okay. Now let's find our range, which is our y values. So the lowest y value I have, notice if I look way down, this arrow that's going off to the left is also going down. So this is going to keep going and going and going and going, right? So no matter how far down my y-axis I go, I will always be able to find a y value that's a little bit further down, so more negative. So this one's going to start at negative infinity. So it starts as far down as I can possibly go. And when I start coming back up, notice as I come up my y-axis, it stops right here at this value, right? From here to here, I have no y values, which means I can't include that in my interval notation. So the point at which it stops is negative 1, 2, 3, 4. So I can go from negative infinity up to negative 4. Because it has a closed dot at that point, then I include negative 4. And then I skip all the space where I don't have a y value, all this mess, and I figure out where my next y value starts, which is at this point, which has a y value of 2. Again, it's a filled in dot, so I'm going to use a bracket on my 2, and it's going to keep going up to positive infinity because that arrow keeps going up and up and up. Okay. All right, let's look at another 2, and then y'all can work on yours. All right, so this one's a little bit different. When I look at my x's, I look the furthest to the left. When I look as far left as I can go, this arrow is going to keep going. Okay, so I can go from negative infinity to the left. When I start going to the right, notice what happens is I stop at this x value right here. As I come this direction, boom, my graph stops at negative 1. So I'm going to put a negative 1 in with a bracket because there's a closed dot there. And then I'm going to skip all this dead space where there's no x value. Okay, and notice my x's pick up again at this spot right here, which is an x value of 1, 2, 3, 4, 5. Since it's a closed circle, I start with 5 and a bracket. And then this next piece is going to keep going to the right. So it's going to go out to positive infinity. Okay. Now I want to do the same thing with my y values, with my range. Okay. The lowest y value that I can have is this y value right here, which is negative 1, 2, 3, 4. And notice it's not a range, right? I'm not going from negative 4 up to something. It can only be negative 4. There is no slope. This is a zero slope line, which means I don't have several different y values. I just have a y value of negative 4 on that piece. Okay? When you just have set values, it's not like from one number to the next. We use set notation. So here, the y value can be negative 4, and the only other y value it can be is this other piece, which is up here at positive 10. So I'm going to use set notation with curly braces to basically say y can be negative 4 or it can be 10. Okay? We can't use interval notation because if we use parentheses or brackets, that means negative 4 to 10 and everything in between. And here it can only be negative 4 or 10. Okay? Okay, this is a circle, but I can still find domain and range. I look the furthest x value to the left, which we're going to pretend is this line, because when I created it, the circle was supposed to stop there. Okay, so we're going to pretend it lands nicely on that line, which is at x equals 1, 2, 3, 4, 5, 6, negative 6. Since it goes through that value, I'm using a bracket. So from negative 6 over to the other side of this circle, which stops here, which would be at positive 11. Again, it goes through that value, so I'm going to go ahead and use a bracket. Okay. Then I do the same thing with my y values to get my range. My lowest y value would be this value right here, which is negative 10, again with a bracket. And my highest y value would be this right here, which is 1, 2, 3, 4, 5, 6. Okay. So my x's go from negative 6 to 11. My y's go from negative 10 up to positive 6. All right, let me look at 2 more. All right, this next one, looking at domain and range. If I look at my x's, it's easy to see there's no stops, there's no starts in this line. It just keeps going from left to right. The arrows say it's going to keep going and going and going, which means that my domain or my x values are going to go from negative infinity to positive infinity. Okay? And then I want to look at my y's. My y is the same thing as true. Now it's not dramatically increasing, but because that arrow shows that it's going to keep going up and the left arrow shows that it's going to keep going down, my range here is also negative infinity to infinity. Okay, keeps going left and right, keeps going up and down. Let's look at one more. My last one, for my domain, I look at my x's and I'm looking how far to the left can I go. And the furthest left value I have is this one right here, which would be negative 1, 2, 3, 4, 5, 6, 7, 8. Because I have a closed dot, I can go from negative 8 out to the right. And notice out to the right, that arrow is just going to keep going and going and going. So if it keeps going out to the right, that means it goes from negative 8 to positive infinity. Infinity always has a parenthesis. Okay? And then we look at our range on this one. So we look at our lowest y value, which here, the furthest down this graph is going to go is as far down as I want it to go. Notice it has an arrow that's going to keep going lower and lower and lower at a slow rate, but still it's decreasing. Okay, the lower it goes, the more y values we have. Since there's no stopping point, that means the lowest y value I'm going to put as negative infinity with a parenthesis. Now my highest y value, if I look to the top of this graph, I don't have an arrow that keeps going. I have a dot where it stops. So all I have to do is record that y value, which here is a positive 9. And I include it with a bracket. Okay. All right, that is the end of your Pre-E2.5 domain and range review. There is a worksheet for this assignment, which you need to print out, work it by hand, scan and email it to me, fax it to me, something of that sort. Okay. If you have any questions, please let me know.